This is a recast of the 4,300-word piece, Multi-Layer Perceptron, MLP, from Xinpat AI. This article discusses multi-layer perceptrons, MLPs, their components, applications, and advantages/disadvantages. Let's listen in.
Today we will be discussing multi-layer perceptrons, which are an important type of artificial neural network. MLPs are widely used to solve complex problems, including classification, prediction, and pattern recognition tasks.
Yes, MLPs are made up of multiple layers of artificial neurons that are organized in a feed-forward manner. This means the neurons in one layer feed information to the next layer until the output layer is reached.
Exactly. That's why MLPs are good for deep learning challenges. The input layer receives the data, and the hidden layers process the data using non-linear activation functions. This is why they can be used for tasks like handwriting recognition, fraud detection, and sentiment analysis.
MLP is crucial because of its vast applications in various fields, such as intelligent systems, robotics, finance, medicine, and image processing. It has the ability to detect patterns and make accurate predictions from data, which reduces human errors and saves time.
It can also provide insights into how the human brain processes information. This makes it an essential tool in cognitive science research. The founding fathers of MLP are Paul Werbos and Jan LeCun. They have contributed to the development and advancement of this neural network model.
Werbos is credited for introducing the concept of backpropagation, which laid the foundation for the training of MLPs. LeCun's work on convolutional neural networks has propelled the field of computer vision and has led to the development of innovative applications like autonomous driving.
Early uses of MLP were primarily focused on pattern recognition and classification tasks. For example, they were used to classify handwritten digits, letters, and symbols for optical character recognition, OCR. MLPs have also been applied in various fields like finance, engineering, and medicine for credit risk assessment, stock price prediction, process monitoring, and disease diagnosis.
Over the past few decades, extensive research has been conducted to improve MLP performance, and a plethora of modifications have been introduced. These advancements include the development of deep learning models that allow for more complex and sophisticated architectures.
The architecture of multi-layer perceptron, MLP, consists of an input layer, one or more hidden layers, and an output layer. The input layer receives input data and passes it to the hidden layers. The hidden layers compute a nonlinear transformation of the input data using activation functions and send it to the output layer. The output layer computes the final output based on the input data and hidden layer outputs.
The layers in the MLP are important because they enable the network to learn increasingly complex and abstract concepts. The neurons in each layer help to compute a nonlinear transformation of the input data, which provides greater flexibility in modeling complex relationships between inputs and outputs.
Additionally, researchers have experimented with various activation functions, such as the rectified linear unit, ReLU, which has been found to speed up the learning process in deep networks.
To train an MLP, we use an optimization algorithm called backpropagation, which computes the gradient of the loss function with respect to the weights and biases. The gradient is then used to update the weights and biases in the network, with the aim of improving the performance of the network on the training data.
Additionally, the use of GPU accelerators in processing and training MLP models has significantly enhanced their performance in handling big data applications.
So that's a brief overview of MLPs and some of the developments that have been made in recent years.
The backpropagation algorithm is one of the core components of an MLP network. It's used to adjust the weights and biases of the network during the train phase.
It works by computing the error between the predicted output and the actual output, and then propagating it backwards through the network to adjust the weights and biases. This process is then repeated for each training example until the error is minimized.
The backpropagation algorithm is a fundamental component of supervised learning in neural networks, so it's essential for the MLP to learn from data and make accurate predictions.
So that's the basics of backpropagation. What about regularization techniques?
Regularization techniques are a critical component in ensuring that neural networks, such as the MLP, do not overfit the training data and generalize well to unseen data.
Techniques such as L1 and L2 regularization add a penalty term to the cost function. which incentivizes the network to learn weights with smaller magnitudes, thus reducing the risk of overfitting. Then there's dropout regularization, which involves randomly dropping some neurons during training to force the network to learn more robust features and reduce co-adaptation.
Together, these regularization techniques will help us build a better model that generalizes well to unseen data.
Absolutely. Now let's talk about some of the applications of MLPs.
Multi-layer perceptron algorithms have been widely applied in various fields such as speech recognition, computer vision, natural language processing, and finance industries.
MLPs are often used in speech recognition because they can identify spoken words from audio signals with high accuracy. They can also be used in computer vision to identify patterns in images and recognize objects in a scene.
In addition, they are used in finance to predict stock prices and identify trading opportunities based on market trends, as well as natural language processing to understand and analyze human language.
Right, so we discussed some of the practical applications of MLPs. What about image recognition?
Image recognition is another application for MLP models. This includes identifying and detecting objects or patterns in images automatically.
Currently, this technology is used for security systems, medical imaging, and even social media platforms that use image recognition algorithms to improve user experience and content moderation.
MLP-based image recognition models can detect and recognize all sorts of objects, including faces, animals, colors, shapes, and more. This is a powerful tool for improving image recognition technology and making it more efficient and accurate.
Absolutely, image recognition is an important area where MLPs really shine. Now let's talk about another popular application, financial forecasting.
Financial forecasting is an important use case for MLP models due to their ability to learn complex patterns and relationships present in financial data.
They can be used to predict future financial trends, evaluate risk, and optimize investment strategies. However, MLP models still require careful analysis and interpretation of their predictions to ensure reliable results due to external factors that could influence their accuracy.
Lastly, let's talk about speech recognition. Speech recognition has been a challenging field of research for decades, but thanks to MLPs, significant progress has been made in recent years.
Today, speech recognition technology can be found in many applications such as Siri, Google Assistant, and Amazon Alexa. While this technology has drastically improved, there are still some challenges like different accents or noisy environments that need to be addressed before we can rely on them completely.
That's it for applications of MLPs. Now let's talk about some of its advantages and disadvantages.
MLPs have several advantages over other machine learning algorithms, such as their ability to learn nonlinear decision boundaries and their high accuracy in classification problems.
On the other hand, there are also some disadvantages, such as dependency on dataset size, which could lead to overfitting or local minima, which can decrease accuracy. Additionally, MLP is a black box model, which makes it difficult to interpret its results.
That's all we have time for today.
Additionally, advancements in image processing have allowed for the development of more specialized neural networks like convolutional neural networks. These networks are best suited for image recognition tasks, while recurrent neural networks are best for processing natural language data.
Finally, there are numerous new trends and applications emerging with MLP, such as deep MLP architectures, incorporation of other AI techniques like reinforcement learning and natural language processing, and utilization in more industries.